When you think of farming, you likely picture massive open fields, rich topsoil, and crops soaking up months of direct sunlight. Every major food staple we rely on needs exactly those three ingredients to survive. Inside a commercial mushroom farm, those rules disappear. There is no dirt, there are no tractors, and the environment operates with absolutely zero sunlight. Instead, millions of crops grow on stacked metal shelves inside heavily sealed laboratory-like rooms. This method of agriculture exists because mushrooms are fungi. They belong to a completely separate branch of life, with biological needs that are distinct from any vegetable on your plate. Biologically, the familiar cap and stem you buy at the grocery store is a reproductive fruit, a temporary structure grown by a much larger, hidden organism. This diagram shows how the actual living creature is hidden out of sight. It's a vast, microscopic underground web called mycelium, which acts as a dense structural network feeding the temporary fruits that eventually break the surface. The commercial mushroom industry is built around a singular challenge: mass-producing this invisible subterranean network entirely indoors, without a single drop of sunlight. If you plant a mushroom in standard farm dirt, it will die. Fungi require a highly specific, engineered food source to survive. Growers solve this by creating specialized compost. They mix massive quantities of wheat straw, poultry manure, and a mineral called gypsum in large outdoor facilities. As this mixture sits, natural microorganisms begin to break it down. Over several days, this microscopic activity spikes the temperature of the piles and alters the chemical composition into the exact diet the fungus requires. With the food ready, it's time to plant. But mushrooms don't drop seeds. Instead, farmers use something called spawn, a carrier material preloaded with living mycelium. During a phase called spawning, workers mix this living web directly into the compost. The mycelium begins consuming the dark organic material, stretching its root-like threads in every direction until the bed is fully colonized. In just a few weeks, that pile of agricultural waste is transformed into a solid, living fungal grid that acts as the battery to power the eventual harvest. Now that the network is fully established, workers cover the top of the compost beds with a special moist material known as a casing layer. This damp blanket serves as a biological trigger. Hitting this specific physical barrier signals the mycelium to stop its horizontal spread and begin pushing vertical fruits toward the surface. This chart shows how narrow the survival margins are for a mushroom crop. To keep that fruiting process going, modern farms rely on tight computer controls to lock in hyper-specific levels of carbon dioxide, humidity, and temperature. The environment is incredibly fragile. A temperature shift of just a few degrees or a slight drop in moisture can stall the biological process and ruin the entire crop. But when the climate is dialed in perfectly, the compost surface erupts with thousands of tiny white dots known as pins. These pins grow at an exponential rate. In a matter of days, they balloon from tiny specks into thick, fully formed mushrooms. This requires round-the-clock observation from the farmers. Success in this industry depends on maintaining a hyper-calibrated environment, turning a warehouse into a precision instrument designed for a single fungal outcome. Because mushrooms grow at different speeds, harvesting is done entirely by hand. Workers select each individual cap, evaluating size, color, and quality before picking it. The harvest continues for weeks. A single compost bed can push out a second and sometimes even a third wave of new mushrooms in a biological phenomenon known to farmers as a flush. The moment a mushroom is detached from its network, the clock starts ticking. Fungi hold an incredibly high volume of water inside their cells, making them uniquely vulnerable to immediate rot. To reach the kitchen in time, crates are rushed straight from the growing beds into high-powered cooling rooms. This sudden drop in temperature slows the organism's metabolism, preserving its shelf life. The entire back end of the operation pivots. After weeks of stimulating growth, the facility must now focus on total biological preservation to ensure the crop survives the supply chain. From those cold rooms, the crop is packed and shipped out into the bright, temperature-controlled aisles of commercial supermarkets. This single production process supplies a massive variety of end products, from fresh produce bins to dehydrated packets and canned ingredients for thousands of processed foods. It's easy to pick up a carton of mushrooms without a second thought, but getting them there requires a sterile, sunless journey that operates outside the standard rules of agriculture. Modern mushroom production relies on a deep understanding of microbiology to bypass the need for seasons and sunlight. By replicating a forest's decomposition cycle inside a sterile box, farmers have turned a wild fungus into one of the world's most consistent food supplies, all without ever needing the sun.